we are going to use the method of slicing to find the formula for the volume of a sphere with radius r. Now, as you can see, this is a sphere. When we slice a sphere, the cross section is a circle. And as you know, the area of a circle is pi r squared. Well, when we use the method of slicing, step one is to sketch our solid, and we're going to make sure we get the x and y axis in there. And we have a sphere of radius r. And I'll throw a little three-dimensional stuff in there just so you can see. We slice it, any old place. And when we open up the cross section, at that spot, here's what we have. We have a circle with the x-axis coming out at us. Now the question is, how tall is this radius? Well, that's y. That means this distance here is y. And for step two, of course, we have to find our a of x. Well, our a of x is going to be pi y squared. But you can't have y because there's too many variables in there, so we have to find a formula for y. And as it turns out, this half circle here, this distance here is the square root of r squared minus x squared. That's what y is. And when we square that, of course, we end up with pi times r squared minus x squared, the quantity. Okay. The limits of integration, as we're slicing along the x-axis, are going to be from negative r to r. Our whole goal is to slice this thing up and add up the slices. And we're going from negative r to r on the x-axis. So, little a is going to be negative r, and little b is r. And now we're going to set up our integral and go ahead and do the calculus. So, the integral from negative r to r of pi r squared minus x squared dx. That's the thickness of our slice. Now we're going to have to use a whole bunch of rules of integration, like the constant multiple rule, where we bring out the pi. And then I'm going to use the difference rule to break this up into two integrals. And that's going to look something like this. Remember, r is just some constant radius for our sphere. On page 425, number 9, let me check that. On page 425, number 19, the radius happens to be 9. Excuse me, the radius happens to be 3. R squared would be 9. Okay, so we break this up. We got a minus sign. Antiderivative over here is just the constant times x. So this is going to be pi r squared x between negative r and r And this is going to be pi x cubed over 2, or 3, from negative r to r. Substituting in r and negative r on this side with the fundamental theorem of calculus part 2, big F of b minus big F of a, we end up with pi r cubed plus pi r cubed, because this is a minus negative r cubed is negative r cubed, so that's plus r cubed on this side. On this side we have pi r cubed over 3 minus on this side we have pi r cubed over 3 minus a negative pi r cubed over 3, so that makes this a plus. So 2 pi r cubed minus 2 pi r cubed over 3. Well, this is 6 pi r cubed over 3 minus 2 pi r cubed over 3, and that turns out to be 4 pi r cubed over 3. You might be more familiar with 4/3 pi r cubed. And now you know where that formula came from.